So today's lesson, we're talking about the engineer practice. So that we solve this problem. A final starter kit consists of supplies at the low, carrying a 10 ampere socket outlet and is protected by the 20 ampere Type C circuit breaker. So we have to determine maximum for loop impedance and final starter kit based on the 230 volt when the supply are available. So this means that it's given the socket outlets are rating. So there is a 20 ampere Type circuit breaker, Type C circuit breaker is given. So Type C circuit breaker and 20 ampere is a rating is given. So circuit breaker Type C, the rating is current is a 20 ampere. So we have to find out the for loop impedance. So in this case, I will to refer the table 8.1 of the AS3000. So AS3000 table 8.1. We look at the table 8.1 of the AS3000. So we refer the AS3000 rule and we find out the tables are 8.1. So this is the you see that this is table 8.1 here. So Type C circuit breaker, here is Type C circuit breaker. The Type C circuit breaker, we saw it. And this Type C circuit breaker is 20 ampere rating. So 20 ampere Type C circuit breaker. So that will be the 1/5. So for loop impedance is 1/5 ohm. So this is the for loop impedance. We can calculate 1/5 ohm. The next problems are from the table 8.1. Determine the maximum value of the for loop impedance to cause a Q. This is below to operate in the nominator die. The Q rating 10 ampere required tripping time 0.4 seconds. So the Q rating 10 ampere required tripping time 0.4 seconds. So we have to find out. So supply voltage is at 230 volts. So we have to find the for loop impedance. So we see this. Look at the table 8.1. So here 3000 root table 8.1. So this one is given the 10 ampere and tripping time is 0.4. So 10 ampere is a rating, tripping time 0.4. So 10 ampere here, tripping time is 0.4 seconds. So here we got the 6.4 ohm. So that the 230 volt is divided by 6.4 ohm. So this is then we got the 230 volt divided by the 6.3 ohm. So you got 35.9 ampere. And then also the Q rating 10 ampere, tripping time 5 seconds. So in this case, we find out the 10 ampere and 5 seconds. So this is the for loop impedance is 9.2 ohm. So tables are 8.2. We find out there's a 9.2. Table 8.2 is a phase of 433 of the AS3000. So the protected device rating is 10 ampere. And there's a 5 seconds, so the 9.2 ohm. So then 230 volt divided by 9.2 ohm. So we got the answer. So that will be a 230 divided by the 9.2, you got a 25 ampere. So this is the way we calculate the operating current. So the next one is a 2.2 kilowatt quick recovery water heater. We find out the HRC Q protection. So 2.2 kilovolt, 2.2 kilowatt quick recovery water heater is protected by the HRC Q processing. So we have to find out the maximum demand current, the Qs to protect, and the current rating carrying capacity of the cable. This one is partially surrounded by the insulation. So in this case, we have to utilize a V75 cable. So the firstly, we have to find out the configuration of the protection. This is the IB less than or equal IN less than or equal IZ. IB is a maximum demand current. IZN is a protected device current, and the IB is a maximum demand current. IN is a protected device current. Protected device rating. IZ is a cable rating. So this is the IB less should be the less than or equal IN or should be less than or equal IZ. This is the first condition. Second condition is operating current I2 must be less than the 1.45 times IZ. So the 1.45 IZ is a current cable rating. I2 is an operating current condition. So this is for the protected device rating. So in this case, we had to utilize the cable here, and then we had to utilize the 1.5 millimeter square cable. This arrangement for the short circuit protection is given. Okay, so this is the things that we have to find out. In this case, firstly, we have to find the 2x2 kilowatt quick recovery heater. So we had to find the maximum demand current. So maximum demand current, we utilize the table C1, C2, or C3 of the AS3000. So in this case, domestic means that we have to utilize the table C1. Table C1, quick recovery heater. So table C1, we go to the look at the see at the page 464 of the AS3000. Quick recovery heater. And we find out so that we see that 400. So 464. So 464 of the AS3000. 464. So that we here is you see the table C1. This is for the maximum demand calculation. So the column 1 is a load group. Column 2 is a single domestic installation. Column 3, 4, 5 for the block ribbon unit. So this is the things that we what kind of the load and what kind of the place of installation. Depending on the type of the load group and the place of installation, we have to determine the appropriate maximum demand current by using the table. So in this case, we find out the quick recovery heater. Quick recovery heater is a slurry water heater the same. So this is for the load group is a F. So in this case, this is a single domestic installation. So column 2 is this way we have to utilize the full load current. So maximum demand equivalent to the full load current. So full load current, how do you calculate? This is a slurry water heating kilowatt is divided by the supply voltage. Then you can calculate this full load current. So then we have to find out the kilowatt. It's a 2x2 kilowatt, 2x2 multiplied by 10 power 3. Supply voltage 230 volt, so you got a 9.56 ampere. So this is the full load current is a 9.56 ampere. So in this case, the IBS, the maximum demand current is 9.56 ampere. So we calculate that. And then we also have to find out the fuse protection. Fuse protection. So in this case, 9.56 ampere. So fuse protection IM must be the greater than the 9.56 ampere. Because according to this equation, IB is the maximum demand current, IN is a protected device rating. Protected device rating must be greater than the maximum demand current. So we look at the tables 8x1 of the AS3000. So the table 8x1 is a page of 433 of the AS3000. So we look at the 433 of the AS3000 rule. So in this case, fuse protection. Fuse protection is a 0.4 second fuse protection. So that will be the 9.56 ampere is a given. So this is the protected device rating. That if you select the 10 ampere protected device rating, so that will be the follow impedance is a 6.4 ohm, and so this is a greater than the maximum demand current. So firstly, we temporarily select the 10 ampere rating because of the 10 ampere fuse rating is a greater than the 9.56. So this is we select the 10 ampere. In this case, this fuse protection maximum follow impedance is if you use a HRC fuse, that will be the 6.4 ohm. So we select 10 ampere rating. So we select the 10 ampere rating. So that will be IN is much greater than the ID. Then we have to find out the IZ. IZ is we have to supply the wire cable side. Cable side we have to utilize the AS3008. So there are 3000 AS3008 got there's a 4 saturation. So if you select the cable in this air, there will be enclosed cable. So table 3x1 have to utilize. It's a cable enclosed. In this case, you have to utilize the tables 3x2 underground installation are included at table 3.3. Underground enclosure at table 3.4. Now, this program is given all surrounded by the insulation, partially surrounded by insulation. So there will be the enclosed. So the partially surrounded enclosed. So therefore, this is why that we have to utilize the table 3.2. Table 3.2 we have to utilize. So table 3.2 we have to utilize. Another thing is a water heater is a domestic installation. Domestic installation is that there will be the two single core cable utilized. So two single core cable, and we find out that we use at table 3.2. So that we look at that AS3008. So this is the AS3008. We find that the table 3.2. So we go down and then look at the table 3.2. So there will be table 3.1, 3.2, 3.3, and 3.4. So 4 table here. We look at the table 3.2. So section 3. So this is table 1. So this is how to utilize a table. So we look at the table 3.2. So table 2. Table 3.1. This is enclosed. Here is a table 3.2. Enclosing air. So enclosing air cable 3.2. So two single core cable we just utilize. And partially surrounded by insulation. This is the partially surrounded by insulation. Two single core cable. So two single core cable partially surrounded by insulation. So there will be table 4, 5 or 6. They have to utilize. So this is item number 3. So then we have selected item number 3. Table 4, 5. So table 4, 5 item number 3. So table 4, 5 is here table 4, 5 item number 3. So two single core cable table 4, 5. So there will be the column 18, 19 or the table 6 column 13 has to be utilized. So this is the ways we look at the table. Column 18, 19 and table 6. So table 4 for the copper. And this is a table 4 for the 75 degrees centigrade, table 5 for the 90 degrees centigrade, and table 6 for the 110 degrees centigrade. So there are 3 situations. So depending on this operating temperature of your wire, if you use as 75 degrees centigrade operating temperature wire, we have to utilize the table 4. 90 degrees centigrade operating temperature, we have to utilize the table 5, or 110 degrees centigrade operating temperature, we have to utilize the table 6. So this is the table 4, 5, 6 we have to select. In this case, it's given there V75. So this will be the 75 degrees centigrade operating temperature. Therefore, we have to utilize a table 4. So this is the table 4 has to be utilized. So table 4 is utilized. So this is the table 4, column 18, 19. So that from the table 3.2, it's refer the table 4, column 18 and 19. So then delay day is at table 22. But this problem does not have the delay day. It does not mention about delay day. So only we have to utilize the look at the table 4, column 18, 19. So then we go down and then look at the table 4. So that from the table 3.2, it refers to the table 4, column 18, 19. So here is the table 4 here. So this is column 1 to 13. Go down and here you see the column 18, 19. 18 for the, this is for the copper, 19 for the aluminum. So 18 for copper, 19 aluminum. So this is the copper and aluminum, we got it. So from this cable, we are using if you select the 1.5 millimeter square, firstly we start from select the cable. So the minimum cable size is at least 1.5 millimeter square. 1.5 millimeter square, in this case, if you select the copper, the maximum demand, the current is 40 ampere. Cable rating current is 40 ampere. So then we utilize. So in this case, here is we can now get the fuse rating operating maximum demand current is 9.56 ampere. And then we can utilize the cable's rating will be the fuse protected device rating is 10 ampere and maximum demand current of the cable reading is 40 ampere. So that we can utilize IB is a maximum demand current 9/56. Protected device reading is 10 ampere IN, and cable reading is 40 ampere. So if we agree with the IB less than IN less than IZ, so if you select the tables are 1.5 millimeter square, this is we just have first condition. But we still need to satisfy with the second condition. Second condition is, here is the second condition given. Operating current I2 must be less than the 1.45 die IZ. So the IZ is we calculated. IZ is a 1 by, if you set the IZ are 14 ampere, 14 ampere, 14 multiply 1/4, you got a 20.3 ampere. IZ is 20.3 ampere. I2 is an operating current. How to calculate the I2 operating current? So I2 operating current is, if you select the 10 amperes of fuse rating, we have an approximate table 8.1. That will be the following impedance is 6.390. So here you see there's a table, here's a 3000 tables 8.1. If you select the protected device ratings are 10 ampere, in this case, following impedance is a 6.4 ohm. So this 6.4 ohm is a following impedance. So the 234 divided by 6.4 ohm, then we can calculate the operating current. So operating current by this way, 230 divided by 6.4, we calculate the operating current. So 230 by 6.4 is 35.94 ampere. I2 we got. I2 must be less than the 1/45 like IZ. So 39 by 5.94 less than 1/4 IZ. So the IZ we calculate is here you got the 24/8. IZ is 24/8. Now you select the only the IZ is a 14 ampere is not enough. So we must select the higher rating 24/8. Based on the 24/8, we must utilize the higher rating. So in this case, we look at this AS 3008. Okay, so we can utilize a 1.5 millimeter square. We cannot utilize. But if you select the 2.5, the current is only 20. Now what you got the current is, here is a this current is you got a 24/8. 24/8, so we have to set as appropriate side. The appropriate side is a 40 ampere 1.5, 20 ampere 2.5. So 24/8 is around nearly 25. You got a 4 millimeter square. So cable size is 4 millimeter square. We selected. So this is the way now we got the answer. Cable size is 4 millimeter square. So this is the way we calculate. So therefore, in this problem, if you select the protected device rating, 10 ampere protected device rating, and maximum demand current is 9/56, IZ value is 25 ampere, cable size 4 millimeter square. So this problem is we select the appropriate cable size to satisfy with the protection configuration. So firstly we select the IB by using the maximum demand cable. Tables are table C1, C2, C3. This is the things we select this maximum demand current, and then based on the maximum demand current, we select the appropriate protected device rating, and then we compare with this equation. Utilize this equation. IZ equal to I2 must be less than the 1/4 like IZ. So from here you got the IZ. So based on this IZ value, we use the ASR 3008. They were 3/2 because of partially surrounded. So enclosed in L. And from this equation, we can select the appropriate cable size. So in this case, two single cable saturation. So we select the item number 3. So this item number 3 of the ASR 3008. So item 3 of the AS 3008. So this item 3 of the AS 3008, because of we are selecting the two single cable, so it's referred to the table 4, 5, and 6. So the table 4 for the 75 degrees centigrade operating temperature cable, table 5 for the 90 degrees centigrade operating temperature cable, and the table 6 for the 110 degrees centigrade operation temperature table. So in this case, we use the 75 degrees centigrade, B 75. So we refer to the table 4. So we refer to table 4, and then column 18, 19. So table 4, column 18, 19. We got it. So this for the copper, we utilize the table columns are 18. Then 4 millimeter square. So this is 25 ampere current. So this is for the cable selection. So this program shows the protected certified configuration as well as a cable selection. Okay, so then we utilize a residual current device, RCD. RCDs are the residual current device. When the electrical fault current is up for happen, the off fault current is sensed by the RCD and then trip off the supply. So this is the RCDs construction. RCD got the dot right go, and this is a incoming current and outgoing. So normally the current I1 is from the supply to load current, and current I2 is a return current from load to the supply. Normal condition, I1 is equal to I2. There is a no trip current. So normal condition I1, I2 is equal. RCD does not detect the imbalance current, so there is a no trip. But when the upfault happens, so some of the electrical current will flow to the arc. So this is the some electrical current from the drain currents are flow to the arc. So the I1 and I2 will no longer be equal. I1 is greater than the I2. So there's an imbalance current happen. Here is a I1 current, here some R current go to the upfault, and then the I2 is coming, so I2 less than the I1. So I1 is greater than I2, so imbalance current happen. Because of the imbalance current between the I1 and I2, RCD detect and trip the supply circuit breaker. So this RCD detect trip circuit, we cut off the supply. So this means that sometimes we are supply not available because RCD has already tripped the upfault current. So in this case, you cannot reset the RCD because you need to find out the upfault current and you have to clear the upfault current. After you clear the upfault current, then you can trip the RCD. Otherwise, when you trip, whenever you reset the RCD, RCD will be tripped off because of the upfault is still exists. Therefore, when the RCD trip off and the supply is off, what you have to find out is there might be some upfault current because of some insulation broken down and the current flow to the arc. So you have to find out the upfault, and then you have to clear the upfault first, and then you can reset the RCD. So this is the way RCD tripping is an important aspect. So there are the type of the RCD. Type 1 RCD is depending on the unleaking currents and residual current, RCD types are selected. Type 1 is 10 milliampere. Type 2 RCD 10 to 30 milliampere. Type 3 is 30 to 300 milliampere. Type 4 is 30 to 300 milliampere with the die delay. So those are the type of the RCD. So we also got this portable RCD. Type L is a household application. We can utilize the type L. And general industrial application, we can utilize the type H. So the RCD can be operated by the AC or the DC. AC type is you can only use the AC only, and also the type A is AC, and also you can utilize the percentage of DC. Type B you can utilize the AC, percentage DC plus continuous fault current. So those are the kind of this fault current rating. You have to select the RCD type 1, type 2, type 3, type 4. And portable RCDs are type A and type H depending on the household and general industrial. And also whether you are using the AC or DC, you utilize the AC type or A type and B type. So this is the way you utilize the RCD. So maximum one RCD can protect the maximum 3 final sub-circuit. So they must not be more than the 3 final sub-circuit. So one RCD have to protect the maximum 3 final sub-circuit. And more than 3 final sub-circuit, you have to arrange another RCD. 2 RCD. If sometimes you are utilizing 2 RCD. In this case, more than the 1 lighting circuit. If the lighting circuit more than 1, you have to utilize 2 RCD. So in this case, they are light 1, light 2, lighting circuit group 1, lighting circuit group 2, lighting circuit group 3. So the L1 and L2 utilize the RCD1, and also the L2, L3, L1, L2, RCD2, L2, L3, RCD2. So this is the things are RCD arrangement. So sometimes we also utilize the lightning strike. When to protect the lightning strike, we have to utilize a surge diverter. So in this case, when the lightning comes in, the lightning current is diverted to the ground by using a surge diverter. So this is what the connection of the surge diverter. So this is the ways we connection diagram of the RCD. So that will be the consumer made. So here kilowatt hour meter. So this kilowatt hour meter supply the water heater, and this kilowatt hour meter may and supply the electric range. So and the other things are this supply water heater in neutral go to neutral lane. That one go to neutral lane. So this is the neutral lane. Then neutral lane is connected with the R lane, and also this is the supply neutral. So this is for the kilowatt hour meter for water heater and electric range. So this is for the power connection. But if you are using the electric lighting circuit, so this kilowatt hour, this line connected to the RCD1, RCD2. So this is low group 1 and low group 2, low group 1, low group 2. So this low group 1 neutral connected to the protecting neutral, and also this one connected to a protecting neutral, this RCD connection. And then this protected low is connected to the connection important because of the every water heater, every electric range, and also low must be connected to the arc. Our wire is a green. All our wire are connected and connected to the link. So link and the neutral links are connected at the main by using the main neutral link. So this is the configuration of the electrical circuit. This electrical circuit includes the water heater, electric range. So water heater and electric range are then connected to supply and going to the unprotected neutral. And also that they are also include the lighting and the power source. Lighting and power source are the connected by the RCD. RCD need to protect. And then so those neutrals are connected to protecting neutral. That protecting neutrals are connected. So that protecting neutral and the main arcs are also connected. So this is the way we are connection, configuration of the RCD protection. So this is the points are overload and the circuit protection. So we can use the overload circuit, another overload circuit. So this will be the RCD to RCD protection. So that will be the AC RCD diagram here, AC and passing RCD type A, and AC passing RCN DC and residual as a sinusoidal, that will be a type B. So this is what the symbol of the RCD. Kind of the RCD, they are symbol. Here is a reconnection of the main supply. And here line 1, line 2, line 3, line 2, power 1, power 2 switch. And here RCD1, RCD2 switch. So this is the main switch configuration diagram. So supply main switch, all our red wire is connected to the supply main. And so they are connected to the load. And here is a neutral wire, is a black one. And our wire is a green one. So this connection is a configuration of main switch. And control switch for the line 1, line 2, power 1, power 2, power 3, and also RCD connection. So the RCD connection and configuration of the supply switch, main switch, and also the power active and the neutral, and then connection and the link neutral link. That connection you can see. And also here you say unprotected neutral link. This is protected neutral link. So this is the arrangement of the supply, main switch, and arrangement of the light and the power control switch, and also RCD and protected neutral, unprotected neutral configurations are diagram. So this is the ways we are talking about the protection. Regarding there's a drawing, so this kind of the 3-dimension drawing. It's a drawing here, we can draw the line. So if you look at from the side, you can see that's the diagram. So this is the 3-dimension. You can look at the from the radial side. That way you can utilize a orthographic drawing. So this is isometric. From the orthographic drawing you can see. Here will be the this is a symbol of the diameter. So that will be the section view. So that way this is a develop. We cut from the AA line. So this is the section view. You can see the whole here. This is a cut off a sectional line. So this is section view. We can find out. So here will be the isometric drawing. Isometric drawing, the 3-dimension drawing. This is the whole here. So this is left side and the right side, and then this is bottom. So this is the top view, left view, and the right view. So the top view you can find out like this: left side view here, right side view here, and the front view is here. So this is for the basic drawing diagram. And also you have to view that this electric meter. So this is the isometric drawing. So that's what you can look at that from the side view. You see this is the top view. You can find out like this: left side view and right side view. This is front view. You can find out. So this we can draw the 3-dimension diagram. So this 3-dimension you can select the 3-dimension. So that will be the 30 degree, 30 degree. This is the isometric. If you draw like this, this is 45 degree from the horizontal line. This is the opposite line. So this is the way we can find out the circuit diagram. So here will be the circuit diagram. So this is the real connection diagram of the electrical board, and this is a circuit diagram. This real connection diagram is supplied here. This is the line 1 and line 2, and this switch 1 and switch 2 are protected. Control. So that one will be drawn by the circuit diagram, line 1, line 2, and this switch is control. So that this is for the real connection. Supply switch, they controlling that line 1 and line 2. So this is real connection. Real diagram. So this is the circuit diagram. Supply switch control the line 1, line 2. Here is a wiring diagram. Wiring diagram is line 1, line 2 is here, and this is switch 1, switch 2. So red lines are the supply line, and black line are the neutral, and the green line are the earth. So this is 2 light is controlled by the 2 switch. So circuit diagram 2 light control the 2 switch. So this is for the circuit diagram. This is the real wiring diagram. Here is a real connection. In this connection, you can see that this is a earth link and a neutral link. So this is for the control switch. It's controlling the connecting the 2 socket outlet and also light. So that's wire. So that diagram is we can draw this circuit diagram. So this is a RCD, this one. So 2 power point, and this is switch. This is the light. So this one is a power point, and also this is light wire control. This is power point, and this is the light. So this is RCD. Here will be the protected neutral. This is the unprotected neutral, and this is the earth. So that's configuration. That one we can draw. This is the protected neutral and unprotected neutral. This is earth diagram. RCD here, and this is the light here. So this is the we can draw a circuit diagram. So red line are the active, and black line are the neutral. Green line are the earth. So that is a real connection. Install the electrical device. Here is their circuit diagram. And also that this one is the two light controlled by the 2 switch. So this is for the socket outlet. So this is real connection, and this is the appropriate their wiring diagram. So this is real connection, real installation. So there are 2 light, the 2 switch, and socket outlet. So the 2 light, 2 switch, and socket outlet. So this is the red lights are the supply active wire, black line are neutral wire, and greens are the earth wire. So this diagram, this is real installation. We can represent by the wiring diagram. So and also that this circuit here. So this is also the 2 light, and here control circuit their diagram. So this is also you see the power 1 and power 2 and supply neutral link and Q1, Q2, Q3 and also the power circuit. So this is for the power meter. Power meter ratings are connection P1, P2, P3 and supply neutral link, and this is for the Q1, Q2, Q3 and also supplying and also the main circuit. So this circuit configuration. This circuit configuration is a real connection diagram. So this is what we can utilize the power P1, P2, P3 and supply neutral links, also the Q1, Q3 fuse, and also connected to the divisor and supply connection and also the control link. So this is the diagram. This is real installation. This is for the configuration circuit. Okay, up to this stage, I can talk about the electrical circuit diagram and real electrical installation. So this is the means before the real electrical installation, okay, circuit diagram, and this is the wiring diagram. The real electrical installation, this is circuit diagram. Real electrical installation, circuit diagram. Real electrical installation, circuit diagram. So this is real electrical installation. They are connection. This supplies are switch. Also that this is the light. So this is one main control switch. So this is circuit diagram. Real electrical installation, circuit diagram. So how the circuit diagram we can develop for the real electrical installation. I talk about the real electrical installation and appropriate circuit and wiring diagram. Okay, up to this is we are so the is important. You can need to develop the circuit diagram for the real electrical installation. And similarly, by looking at the circuit diagram, you need to interpret and then you can really install the electrical installation. If you know the circuit diagram like this, you should be able to connect the real electrical installation. This is the circuit diagram. Based on the circuit diagram, you can really install the electrical installation. The circuit diagram, and so by preparing the circuit diagram, real electrical installation need to be constructed. So this is the way, looking at the circuit diagram, how the real electrical installation can be how to where you practically wire up the circuit. So this is where I talking about the principle. Okay, then I went talking about the specification. If you are the electrical engineer, you need to understand the specification. There are types of the electric specification, 3 types. Functional specification is define the function, and also the its rule and the requirement and the solution has to be developed. So this is the functional specification. Performance specification, the purpose, depending on the logical extension of the function and also desired result of the task. So this is the performance. How the performance happen. For example, is a sample is you have to utilize the evaluate pass or fail. Whether you function is you can utilize whether this function can be workable or not workable. So this is the if the function is workable, performance function is workable. This is pass. Otherwise fail. So this is the performance specification, the purpose, whether your real utilize this device in the real application or not. Is the application it can be applied, performance alright. So by evaluation you can pass it, but it cannot perform, it will fail. So this is a performance application based on the purpose. And technical specification is depending on the technical and the physical characteristic, dimension on the circle data side. Those are the technical aspects. So technical and physical characteristics included. Also the dimension, color, properties, and require from the process and the maintenance operation. Those are the technical specification. So based on the functional application, we have to develop the performance. Functional is you have to define the function, rule and requirement, and how the solution. And based on your solution, you have to design the equipment, you have to utilize the equipment to satisfy the certain performance. And then technical, you fathers are develop the technical specification. To achieve the certain performance, you need to utilize the appropriate dimension, appropriate size, or appropriate properties of your materials and requirement, and also the how to produce these devices in the manufacturing. So process of manufacturing, also the process of maintenance, those things are operational. They are technical specification. So we have to plan and analyze. So before you are designing anything, firstly you have to plan, you have to do the analysis. In this case, plan and analysis is depend on you have to collect the appropriate material, you have to engage the people, and also define the requirement, and you have to determine the possible solution, and you have to value the analysis. Those are the development aspect. So therefore, when you are doing the analysis performance, you have to utilize a consultation is important because of you are developing the certain task and a certain function. The worker has to contribute their skill. So in this case, you need to consult with the worker and provide the information. That information is both legal and the quantities in quality information you have to provide. So let's say with the end user and technology staff, we have to cooperate. And then you have to write down the specification. So that specification should be the simple and clear, and also that you have to define the form and the symbol must be utilized, and also that you also have to utilize the appropriate concise, and there must be the user friendly is important, and also specifications are written in a function a paragraph, and also you have to define and you have to draft the specification. And after that, you have to vet in. So you have to submit the application specification to the public or the authorities. So whether those authority publics agree with, if they want to change, you have to change it. This is the vetting time. After there's an issue, everything, all right, everything has been approved, then you issue, and then depending on the public real application, sometimes you have to amend the application, you have to change, you have to a little change. This is the amendment, or this shall have to be done. Also, you have to revise. So this is the how to develop the specification. So after this, this attachment, every specification has to be included. Any attachment, there will be the attachment is a application table or the survey notes or survey application method. They need to use an appropriate title or table and instruction, scope, background, and list of the time and list of the relevant documents. So those are also included in your specification. There must be the title, there must be the appropriate table and the contents, and also the introduction must be included as scope of the application. For example, here 3000 rule, we can only utilize for the utilization side. We can use all the transmission on distribution. Distribution side, we will utilize the user with electrical service rule. So this is the scope. Here 3000 only applicable for the utilization side. Also, low voltage, extra low voltage, but you can utilize for the medium voltage or the high voltage. So this is the scope. Every specification must have the scope. And also, introduction is important. And then also we have to utilize the background information. How this specification is developed, how to change it, how application, those things are background information need to be included. And then list of the item, list of the table, list of the relevant document must be included. This is how the specification is developed. So in this lesson, I'm talking about the appropriate circuit development, also the use of the protected device rating. So here is you can see that this one is a neutral link, this is the outlet, and this is the socket outlet, and here is a RCD, here switch, and this is the light. So this circuit diagram. Here is a RCD, here are the fuse holder, and they are connection diagram. When you are using the electric circuit, electric power switch or the measuring power meter, where do you utilize this circuit? So this is RCD. This is the fuse. Here connection are there. We can connect the active and the neutral wire and the out wire. And this is supply neutral link, active neutral link we can utilize. So here we need the connection diagram. So this is for the light, and this is switch, and this is socket outlet. So supply, socket outlet, light switch are conjunct. Here is that this is the socket outlet here. The socket outlets are similar to the office socket outlet. They are controlled by the control switch. That control switch also control the light point. So this is the connection diagram. Okay, so today's lesson, I cover the cables protective configuration and cable selection. Then I also give you the how the electrical wiring diagram and circuit diagram are related to the real electrical installation. Also, I give you the principle about the specification development. So this is for the electrical engineer. So electrical engineer, I give you the electrical engineer practice 1. So page 50 to 86, I explain about the configuration of the protection circuit and also maximum demand calculation, selection of cable by using the AS3008. Then I show you the example, how the electrical wiring diagram and also circuit diagrams are related to the practical installation equipment. I talk about the RCD, how the RCD are utilized, what the kind of the RCD I talking about, and also I give you the basis of drawing principle as well as the idea how to develop the specification. So this is for the electrical engineer lesson. And then we talking about the electrical trade 2. Electrical trade 2 is we talk about the electrical engineer I talk about, and also the electrical trade practice 1. So electrical trade practice 1, page 43. So electrical trade practice 1, page 43 for the higher level trade student. So the sensitivity of the thermostat is the ability of the thermostat to detect the temperature change. So if you are using the thermostat sensitivity, so this is the thermostat when the temperature is any change, the thermostat must be detected and also need to do the appropriate function. So this is what is our sensitivity of thermostat. The sensitivity of thermostat is the characteristic that is a fixed and is not adjustable. The differential of the thermostat characteristic that is a not fixed and is adjustable. So sensitivity and a differential. The differential of the thermostat is a difference in the temperature between the cut in and the cut off points of the supply. The bimetal strip type thermostat used in the low expanding and the nickel rise method. So this is what the properties of the thermostats are question and answer. A vapor pressure type thermostat contains the volatile liquid enclosed in metal capsule. The thermostat in a finite control, this is utilized for this water heater. So they incorporate the can adjustable bimetal strip and is set up the snap action on contacts. A thermostat in finite control now is a mark from the 0 to 10 at the setting position 2. The thermostat contained in the off position is more than the on position. 3. Heat switch on the medium position has one element only in the circuit. In the thermostatic control, the temperature is sensed between the two limits upper and lower. While the multiple light and the power circuits in the domestic installation are to be protected by the two RCD, circuits should be grouped so that the lighting circuits are spread over the different RCD. Looking at the light method of the wiring means that the active and neutral wire is wires to the light. The size of the oven cavity in the microwave oven is influenced by the wavelength. The hidden methods are implied that has a current induced into the workpiece from the AY is induction heating. The halogen heater is categorized as a light energy, high temperature radiant heater. Using the looping and the switch method or the wiring, which wire will not be connected to the light, so active wire should not connect to the light because of looping at the light switch method. The best use of the dielectric heater would be to the laminate plywood shape. This is for the question answer for the electrical is a higher tricks electrical. A metal sheet enclosing the nickel resistant wire in a dielectric of the magnesium oxide is an example of infrared heating. A workpiece is heated by the direct resistant heating method with the given currents are providing the 1000 joule energy. If the current in workpiece is a double, how much heat energy will be doubled to the 4000 joule? Because of the wherever the current is double, so energy is a quadruple. So because of the square function, so that way when the double is a 2, so it will be the 4000 joules. So this is the look at the light method and look at the switch method. Look at the light method is you can see this is switch. So the active wire go to the light here. After that, this point go to the switch and the down wire here, and then there's a neutral wire. So this is out wire. So this is the look at the light. Look at the switch method is the active wire go to switch first and then go to the light, and also this is for the neutral wire go to switch. And also the light and here out wire connection. So this is the look at the light method and this is look at the switch method. So energy is equal to the I square RT. I is current, I resistance, T is die. When you double the current, so that will be 4 times our energy will be 4 times. So this is the higher quick figure. I talking about the configuration of the electrical circuit and also their properties of the switch and the thermostat I talk about. Then regarding the sustainability issue, we are talking about the greenhouse effect. Greenhouse effect means the heat produced by the burning of the carbon, they are accumulated in the space. Those carbon cannot be go out. So because of those carbon greenhouse effect, it can accumulate the heat and it will weather change can be happen. So the carbon dioxide are the greenhouse gas. When those carbon dioxide are accumulated in the air, so this carbon dioxide gas will increase the temperature of the earth. When the temperature of the earth is changing, it can affect the changing of the weather. So the temperature increase the temperature of the earth is a very important aspect. When the temperature increase, it can cause a cyclone, it can cause a melt down the iceberg in the polar region, and those icebergs are melt down, they can produce a sea level will increase. So therefore the greenhouse effects are necessary. This is a greenhouse effect necessary because of the normally plants are producing the carbon dioxide. So those carbon dioxides are absorbed by the plant, and then they are also produce carbon dioxide at the night time. Daytime, the plants are absorb the carbon dioxide, and night times are emit. So those carbon dioxide and the plants and the animals are consume the plants, so they can also eat their food. So the carbon consumed compounds are also taken by the human. When the human die, they can go to earth and can begin the carbon dioxide. So this is the normal nature. This nature is the dynamic itself because of all the carbon production and all carbon consumption by the animal, plant, human, they are balanced. But if the carbons are produced by the industrial plant, so that balance will be destroyed. Therefore, the carbon will be accumulated in the air, so it can produce they are become the greenhouse gas effect. So those carbon contents are changing the weather of temperature of the earth, also the weather. Naturally, the carbon is consumed by the human animals and the plants, and when they die, they will begin the start of the carbon deposit in the ground. The plants consume the stored carbon and emit the carbon dioxide, and the carbon contents in the plant are eaten by the human and animals. By this way, carbon utilization is essential for the life on the plant. But carbon production is a much greater than the nature consumption. Such excess carbon cannot be taken by the human, plants, and animals. They are accumulated in the atmosphere and cause a greenhouse effect that damage the earth. So this is why we have to utilize the emission trading. Emission trading is the price of the carbon. Whatever you are producing the carbon greenhouse gas, you must pay the tax to the government. So this is why the emission trading. This means that all the industry, they realize that they have to pay the money to the government by producing the greenhouse gas. They will try to reduce the production of the greenhouse gas. So this is the emission trading scheme. Good point is the industry realize they must utilize the grains equipment. But disadvantage is that sometimes instead of that they are utilizing the grains equipment, energy reduction, greenhouse gas reduction, they will increase their price. So service price. So this is the pro and con of the emission trading scheme. So the emission trading is a focus on the price gas or the greenhouse gas emission. The power companies will have to purchase the permit that allow the specified level of the greenhouse gas can be emitted. To reduce the amount of the farm to purchase the emission trading permit, the power company must do the process to reduce the power greenhouse gas production. So this is the way emissions trading principle. So they need to have to find a way to reduce the greenhouse gas emission by providing the energy efficient production of the power and by this way emission can be reduced. The disadvantage is that it will increase the power price without ensuring the real impact of emission reduction. So the industrial methods to limit the greenhouse gases are the applying the energy efficient production methods to reduce the use of the energy, which is based on the greenhouse gas emission, or find the alternative ways to operate the machineries to reduce the greenhouse gas emission. So this is the industrial method to reduce the greenhouse gas. Also, using the clean energy system to avoid the use of the energy that produce the greenhouse gas, or the applying the energy management system and the environmental friendly materials. So also the residential energy management system is important to reduce the greenhouse gas. We have to utilize the green energy efficient equipment. We use the solar panel for the electricity and heating, applying the energy management system to reduce the use of electricity, or using the insulation to limit the heat flow into and out of the house and to reduce the needs of the energy usage. So this is the way to reduce the energy and the greenhouse gas. Okay, so this today's lessons we are electrical trade 2, the higher electrical trade. We talk about the energy efficiency, greenhouse gas, as well as the electrical circuits configuration. So that we're talking about the fluorescent lighting. So incandescent lighting is a heat electrical currents are produced. So the electrical current go to the resistor and produce a heat. So we use a H equal to I square RT. I is a current, I is a resistance, T is a time, H is the heat. The fluorescent lighting is a different. High voltage is applied to the anode and ignite the electron. Electron flow to the interact with the gas and produce a light. So this is a fluorescent lighting. Fluorescent light are the discharge lamp. They are the type of the incandescent fluorescent lights are the mercury vapor, sodium vapor light. So this is the fluorescent lighting. So that this is the fluorescent lightings are this electrode here. So that when the electric gas so is connected, the electrons are produced from the electrode and they transfer from the one electrode to another. Here is gas. So they interact with the gas and produce the light. So high voltage is applied at the electrode that ignite the electrons to flow. The electrons are discharged of the electron, interact with the free gas and emit the light. So type of the color, the light color depending on if you use a mercury vapor, it can produce the blue and green. Neon gas, it produces the red, sodium vapor yellow, and the halogen is white. It needs to supply the high voltage at the electrode, they enough to emit the electron. So this is for the electrodes connection here. And so in this case, this is for the preheat of fluorescent light. This is switch, this is bolus, and this is for the electrodes of the connection diagram of the fluorescent light. So fluorescent light is an open circuit, and the gas and the discharge juice can be ionized. The auxiliary equipment starter to command the start up of the gas to ignite, which allow the current to flow. So once the ignition occurs, the resistance of the gas column rapidly decreases and the current flowing in the circuit limited to prevent the juice from becoming a short circuit. So here we do that. And other things that we say bolus. Bolus is the increase electrical potential of the electronic equipment. So that includes the magnetic and electric bolus. So this is the magnetic bolus. That depend on the V equal to L di by dt, chain of the electrical current, it can produce the voltage. So the di by dt, the chain of the electrical current, and A is the inductance, and this is the voltage. So that when the electrical current change, so it can produce a voltage. The voltage are ignited electrons. So this is the magnetic bolus. This electronic bolus is connected. So electronic circuit is produce a switching function. Electronic circuit provides a switching function to increase the voltage to ignite the electron at the electrode. So this is electronic bolus and the switch connection. So there will be it include the inside electronic bolus. It include the equalizer, amplifier, also the power conditioner for the IC chip, and also magnetic output transformer, integrated chip voltage, and then threshold current, so thermal harmonic distortion, and also those are included in the electronic bolus. So include the amplifier and power conditioner for IC chip, and magnetic output transformer, integrated chips for the voltage, and the thermal harmonic distortion. So they are components of the electronic bolus. So the kind of the starter function is allow the switch the electron and thermostat. So bimetal switches are the kind of the starter. The starter function is it can switch off the when the electrical current pass through the bimetal switch or the starter, it becomes hot and different elongation of the metal switch cause the metal switch to bend. When the cutting of the supply is cool and the task contact to allow the current to pass through. So such switching action happen frequently cause a high voltage at the electrode of the fluorescent tube to ignite the electron to flow. This is the function of the starter switch. So this starter switch, their switching function can increase as voltage across the fluorescent length. When the voltage of the fluorescent lengths are high, it can eject the electron. No electron will be flow out. So no electron will interact with the gas and the light will coming out. So this is the ways of fluorescent light connection. So they are the fluorescent length for the compact fluorescent light. So it includes the light, tube, and bolus also. The fluorescent light can cause a stroboscopic effect because of the sometimes because of fluorescent light, some of the running equipment look like stationary, so the people touch those equipment, they can be damaged, they can injure. Therefore, instead of using the ones light, you have to use two light at a different phase. So in this case, they are bolus here, then another light, but here we use the capacitor. By using the capacitor, their phase and the currents of better waveform will be different. Therefore, it can stop the stroboscopic effect. Only all the fluorescent lights are running at the same timing, so it can cause a stroboscopic effect. So to cancel the servo-switching effect, their timing must be different. So to differentiate the timing, we provide the capacitor. So the two fluorescent lamps are operating at a different timing. So by this way, we can reduce the stroboscopic effect. So this is important aspect. How to reduce the stroboscopic effect. So therefore, the connection of the co-cathode lamp, and this is supply connection here, and here is a connection of the fluorescent lamp and the supply. So this is for the, and also the multi-band circuit, we are connecting with this different bolus for their connection. So this one is we are talking about the switching function. Here is a connection of the starter bolus and the AC supply. Here is a rapid starter circuit. Rapid starter circuit, bolus auto transformer, rapid starter circuit connection. So the single poles are switch used in the lighting circuit. So main switch must switch the active conductor. The maximum active resistance of the light circuit protected by a 16 ampere Type C circuit breaker wire with a 1.5 millimeter square active conductor. In this case, 0.610, where you utilize the table 8.1. What is the principal operation of the reverse circuit air conditioner? This is a step in the medium, allow the heat to be pumped. So that we have to utilize the ASR 3000 appendix C. What is the maximum rating required for the circuit breaker 8 kilowatt range in the 220 ampere? How many 10 ampere socket outlet could be connected by the 2.5 millimeter square cable and 16 ampere circuit breaker in non-domestic installation without permanent air conditioning? This is the 8. And final circuit in the domestic installation consists of 5 single and 6 10 ampere double socket outlet. How many double 10 ampere socket outlet could be added to circuit when it is supplied with a 2.5 millimeter square cable and protected by the 20 ampere circuit breaker? This is the one. The double 10 ampere socket outlets are connected with a 2.5 millimeter square cable protected by a 16 ampere circuit breaker in the office with the permanent air conditioning. How many lighting points can be added to this circuit? Answer is 12. A mid circuit in the home has a 340 watt combines exhaust fan heater light connected to it. If the circuit protected by the 16 ampere circuit breaker, how many 10 ampere socket outlet could be connected? Answer 13. How could the high resistance drive can be detected in overheated transmission line? So we use the infrared radiation, and also what is the characteristic determine the depth of the penetration of the heat effect of the induction heating? This is output frequency. So the today's lesson I talking about the lighting. I explain about the connection of the incandescent light, fluorescent light, their operating principle, and also the question and answer. Also, I talking about the energy efficiency and the greenhouse gas. So this is for the lesson for the trade 2. And then we also talking about the lesson for the trade 1. So electrical workshop practice. Okay, so electrical workshop like this is very about. Now we are talking about this working at the height. When you're working at the height, we have to utilize a ladder accident. So when we are using the ladder, so one people is climbing, so one people have to hold the ladder, or you have to tie the ladder, or you have to put the guard. So the correct ladder usage is an important aspect because of the you have to select the appropriate ladder weight height and the ladder weight, and also correct ladder angle. And ladder angle here is this is the ground line, this is ladder. That angle must not be too wide or too narrow. And also effective ladder control is important. So because of one person walking at the height, another person has to hold the ladder, or appropriate tie and the guard has to utilize. Or those ladder must be put onto the even surface, and appropriate guards not be utilized, and that angle must be appropriate angle. So we have to check the ladder in all aspects. So also to work safely, do not work without proper checking. Ladder type can be depending on the low capacity and also domestic trade and the industry. So there are three kinds of the ladder types. Ladder materials are utilized wood, aluminum, fiber, glass, and steel. So the standard are utilized ASR and ZSR 1892.1, 1996 edition for the portable ladder material. ASNSL 1992 portable ladder for timber. ASNSL 1982.5 1996 the portable ladder reinforced plastic. ASNSL 1892.5 the 2000 edition for portable ladder selection and safe use and care. So this is the importance of the ladder. So the different type of the ladder can be there's a single bolt ladder. So this is the maximum length is a 9 meter. Extension ladder maximum length is a 15 meter. Step ladder maximum length is 6.1 meter. So the US purpose ladder, they can use the stock ladder hinge to provide the extension, also platform. We use the podium ladder. So in this case, the low rating, heavy duty low rating is 120 kilogram minimum, and light duty low rating is 100 kilograms maximum. So when we are using the ladder, you have to you can go the top, you have to put about 2 or 3 steps. 2 steps you have to be spared. So this is the correct one, this is the wrong one. Climb the ladder and the sub vibration must be appropriate to the ladder strength. Sometimes you have to climb on the ladder and you have to do the drill machine to drill it. In this case, the vibration must be withstood by the ladder. So that vibration strength and the ladder strength must be the appropriate. So that when you are using the ladder, important is a manufacturer name, important also low rating on the working length on the ladder, important aspect. Those things have to be utilized. So this is the things ladders are utilizing important information about the ladder. So that before you are using the ladder, you need to check ladder safety. All ladder must be inspected on the delivery after suspected damage, and once every 6 months. It's important. Areas are broken, split, crack, decay. So this is a ladder and also the back glass and the bracing. You have to check properly. And style stock must be missing or not. Split, broken, crack, corner. You have to check properly. And also all the screw need to check whether the screw are worn or loose, and broken or the worn or decay or happening. You have to check. And also ladder ram, you have to check. So this is the ladder component of the ladder. This is for the tie, this is the stock, bracing, those things have to check properly. And also the style and the ram, you have to check, or decay, broke, you have to check it. So the step ladders are this is for the we can utilize a fiber, glass, aluminum, and so on ladder. So that you can only step you can walk, but you can walk on here like this. And you have to 3-point connection touching important. Both 2 legs on the ladder must touch the ground, and the top must be against the lay on the wall. So this is 3-point connection important aspect. So this is the ladder connection. When you set the ladder, 3-point connection is important. So point 1, point 2 are 2 legs on the ladder must be properly touched on the ground, and point 3 the top of the ladder must touch with the wall. So also important aspect. So step ladders are important. Step ladders should be utilized fully open. All the step ladder is utilized. Step ladder must be fully open. Another thing that they spread on the equal surface. You do not stand the ladder on the uneven surface. Must be the even surface. The spread must be the fully opened. Never climb on the bracing. Do not stand on the bracing. Important aspect. The worker should not stand above the top and always have the 3 points contact. Do not use a wet timber or the fiberglass. And step ladder and industrial type. Electrical shock can happen because of the sometimes you also have to aware of electrical shock. Electrical wire attached to the ladder and your ladder is metallic. It can cause an electrical shock. So the important aspect. Another thing is the worker height is a normally it's 1.6 meter. 1 meter above the ground. They must have the appropriate buffer zone is important aspect. So here you use as a ladder here. So this is 1 meter here, 1.6 meter and 1.5 meter buffer zone. This is the correct. So total is 4.1 meter. Worker height is 1.6 meter, 1 meter above the ground, and 1.9 meters buffer zone. So if you are working in the buffer zone, you must use a light safety. So the light safety is why attached to the other fixed installation, and then you can utilize. So this is the harness wire is connected. Harness wire is to see the light of the worker. Is attached to the other permanent permanent pole or the permanent column. We attach to the harness wire, and the harness wire attached to the worker. The installation of the repair work is to be carried out. In this case, appropriate fall protection equipment must be provided. So this is the fall arrest must be provided according to the AS NZ1841.4. So that we only climb up to the mid position. If you are using a single ladder, only climb to the mid position. Now these 2 persons carry the ladder, so that they must carry on the same shoulder. So single or the extension ladder should not stand above the ground. So this is for the appropriate ladder construction. And when we are working on this rooftop, so in this case, always have the 3 points contact. Is important aspect. They are used to reach the working surface of the roof. Must extend at least 1 meter apart. So in this case, we are using the ladder. So this is surface. This is for the roof. This must be 1 meter longer. Do not use the wet ladder. Never leave the ladder unattended. Only 1 person should be on the ladder at any time. Never walk the ladder to an adjacent location by standing on ladder and leaving the. In this case, sometimes you are walking on the here. You cannot move from. You can if you are walking on this position and you want to change to another position, you have to go down and you have to change the ladder. This is also ladder position is also important aspect. So the important aspect is that when you are using the ladder, extension ladder never needs a loud. So if you're using an extension ladder, you have to loud properly. So when you are walking, you ever face a ladder. So you are facing the ladder and you go up and you go down. So sometimes to make the fall protection device, elevated wall platforms are utilized. So EWP are you also utilized. So they are the CSR devices and they are the bonded are also utilized. So this is the telescopic Caesar device and boneless are utilized. So the training for the appropriate use is an important aspect. If you are using this EWB, you need to attend the EWB training. Also, that you need to properly maintain the EWB, and also not overreaching by using the EWB is also an important aspect. So this is for the we are talking about this EWB method. And regarding this joining technique, we use a fastening device. We use a thread, bow, and knot. So this is the bow and knot connection. So in this case, the method through the cat screw. So they are tied on the cat screw. So also we use a washer. We use a spring washer and a flat washer. So this is a nut connection. And also this is long nut and this is standard nut is also utilized. The long nut is we adjust the position. So that we also have to utilize set tapping screw. So this is the gimlet wide plastic bolt screw or the flat head and narrow head, mushroom head screw are also utilized. Also the nylon port rivets are also utilized and bigger bagger heads are also utilized. So this is the connection devices. So that we utilize the rivet. So this is rivet gun. So the tie of the rivet gun, we also utilize the rivet. So this is the temporary connection. For the permanent connection, we have to utilize the welding machine. The fusion method, where the material is being joints are they are using the fusion method. So this is MLW is a manual method at welding. So this is so when the electrical current flow here, the electrical currents are heat the electrode melt down, and then they fill with the metal. So this is the electrodes connection. And also to increase the current flow into the electrode, we use a welding transformer. Welding transformer increase the current, and secondary coil, the high current will pass into the electrode and the workpiece. Then the electrode will be heat up, and the metal will be melt down, and they fill with the metal. So the transformer provides the high current at the large enough to make the arc between the flash cover electrode and the water temperature. So this is the temperature it becomes 600 degrees centigrade. So this is for the welding method. Soldering is a process of joining methods together by means of the alloy method into the joint after the application at the suitable place. So this is soldering and the solder connection. Here is the oxyacetylene machine. Oxygen and acetylene are heat up, and from the nozzle we are lighted, and then we can just arc electric arc. We heat the your metal, and then we can provide the electric oxyacetylene welding. Resistance for weldings are utilized to heat resulting from the resistance to an electric current passing through the metal being joint. So this is for the connection of the vice. This is the vice connection. So this is how the tapping the threading diagram. Okay, so this is the ways we are utilize the electric project. So I explained about the connection tapping, also the use of the connection joining method, and also we talking about the electric ladder safety, and the walking at the height. I explain also we use the joining technique. Joining techniques are how to use a tapping screw, threading, or to bolt nut, and electric welding method, soldering method. I explain. So this is for the electrical trade 1 lesson. And regarding the advanced diploma, we look at the site. So advanced diploma, I will give you the video. Electrical Diploma 2022. Okay. And I gave you the video lesson. YouTube video electrical engineering. So now we got the lesson. Last week I have already talked about the OHS E17. So today's we get the circuit, electrical circuit. Today's topic is the series resonance circuit. Series resonance circuit is the circuits that consists of the resistor, inductor, and the capacitor. For these circuits, this is the AC supply. Impedance can be calculated. There is a R plus JHS minus JAC. AC is an inductive reactance. We can calculate by equation. AC is equal to 2 by FL. AC is a capacitive reactance. AC can be calculated. The formula is 1 by 2 by S. So these circuits frequencies are variable. So the frequency changes, H and value also H and value are also changing. At the starting frequency, so H and AC can be equal. So when the H and AC are equal, because of the JH minus JAC, so H and AC will be cancelled. Only resistance is left. So the circuits are impedance is equal to the resistance. So the current can also be calculated V divided by Z, so this is delta V divided by R. This is for the maximum current can be flow. So that we can draw the frequency current diagram, and the resonant frequency current becomes the maximum. This resonant frequency can be calculated. The resonant frequency is FI equal to 1 by 2 by square root of LC. How we call it? And the resonance are S and AC are equal. So the AC are 2 by FA, AC 1 by 2 by SC. So this is equal to the F square is equal to 1 by 4 by square LC. And the FI is 1 by 2 by square root of LC. So this is the resonant frequency. Similarly, we can also calculate the quality factor. Quality factor is the ratio between the reactive power and the active power. So the quality factor is equal to reactive power divided by active average power. So the H by R. In the meantime, this is the frequency. This is the resonant frequency. This is for the half power Y. So that we can draw the graph Fy and F2. The ratio between Fy and F2 is the difference is the bandwidth. Bandwidth you can be calculated. F2 minus F1 equal to F by Q. So this point with the half power Y. Fy and F2 are half power Y. The circuit will draw the half power. So this half power is equal to half into maximum half power. This is for the resonance circuits. Theory and respective equation. Based on this theory, we are going to solve this problem. For the given series resonance circuit, we have to find the I, VR, VN, and the PC as a resonance. The supply voltage is E, then angle 0 ohm, resistance at 2 ohm, inductive reactance at 10 ohm, capacitive reactance at 10 ohm. They are connected to series. So we have to find the Q of the circuit. We have to find the I, VR, VN, VC. And we also have to find the Q. Resonance frequency is 5,000 Hz. We have to find the bandwidth and the power distributed in the circuit and the half power frequency. So the first thing we have to calculate is Z. There is a R plus JHA minus JAC. So the R is a 2 plus JH is a plus J10 minus JH is a minus J10. So the plus J10 and minus J10 cancel. So the current will the system will be 2 ohm. So the current can be calculated E by Z. E is a 10 angle 0, Z is a 2 angle 0, so 5 angle 0 ampere. The currents are 5 ampere flowing through the resistor, so the VI is going to be I multiply R, so you got a 10 ohm.
BS currents are 5 ampere inductive reactance. Then O I multiply HA 5 angle 0 multiply 10 angle 90 for the HL to the 50 angle 94. BC. So current is a 5 ampere, AC is a 10 ohm. I multiply AC 5 angle 0, AC is a 10 angle minus 90, so the 50 angle minus 94. You can calculate the HA by R. So H is 10, R2, so Q is 5. Bandwidth is a FR by Q. The FR is a 5,000, Q is a 5, so that we got the 1,000 half. Half power frequency, half power power, half multiply B maximum. Half into I maximum square R is a B maximum, so the half multiply 5 square is a I maximum square, and R2, so you got the 25 watts. This is called the series resonance circuit calculation.
So this is for the electrical circuits or resonance calculation. The resonance electrical circuit, lesson 2.
This is a parallel resonance circuit. Supply source, current source, and parallel resonance resistance can be calculated. Q square is RI input resistance, and HF is a parallel resonance inductance, and AC is a capacitance. So they are connected in parallel. For the parallel resonance, parallel equivalent resistance is A by RAC. Terminals are impedance. Terminal impedance and the parallel can be calculated. RS parallel RB. RS is a source resistance, RB is a parallel equivalent of resistance. So the RB is the QA square RL, which is the Q quality factor square. RA is a load resistance. You can calculate it. RS parallel QA square RB is a ZTV. Where resonance frequency can be calculated. Fs is a series resonance frequency, square root of 1 minus 1 by QA square. Then we can also be calculated RL by 2 by F. This is called the resonance frequency calculation, circuit calculation, and the formula. Okay, so in this case, the RB is a resonance equivalent resistance, RA is a low resistance, ZTB is a terminal impedance as a parallel condition, QA means a quality factor, and FE means a parallel resonance frequency, bandwidth is the half power frequency bandwidth. Those are the parallel resonance circuits formula. Based on the whole formula, we have solved this problem. For the given network, with the FE is provided, this is the FE provided, FE is 0.04 megahertz. Where to determine the QA, where to determine the RB, where to determine the ZTB, capacitance value, and the resonance. We need to determine the quality factor, QP, and bandwidth. Okay, first we calculate the QA. QA is a formula HA by RS. HA is a 2 by FEL. FE is a resonance frequency. 2 by 3 by 1416. FE is given the 0.04 megahertz, so the 0.04 is 6. Inductance value, the 1 milliampere, and then given, so the 1 multiplied 10 power minus 3. RF value is given, 10. I is a 10, it's a low resistance 10. Low resistance 10 will be substitute, so we call that 25 by 1. RB formula is QS square I. QL we already got is a 25 by 1 square, RS 10, so we have to got it. This is 531 kilo ohm. ZTB, terminals are impedance. The formula is RS parallel RB. RS parallel RB means RS RB divided by RS plus RB. RA is given here, 40 kilo ohm. RB is 6.21. So we substitute, so we got a ZTB 5 by 4.5 kilo ohm. Capacitance C, the formula is 1 by 4 by square F square L. So the 4 by the 3 by 1 square, frequency 0.04 10 power 6 square, and inductance value 1 into 10 power minus 3. From calculation, we got the thing is 15.9 nanofarad. QP, the formula is ZTB by HF. ZTB we already calculated, 5.45 kilo ohm, 5.45 10 power 3. H is a divide F so the 2 by is a 2 by 1 4, F is a 0.04 into 10 power 6, A is a 1 into 10 power minus 3. So you got a QB. Anyway, the formula is FB by QB, so FB is a 0.04 into 10 power 6, QB is a 1.68. So this is the 1.85 kilohertz. Those are the calculations for the Bear-Resonance problem. And based on the those are A and B, C and array, let me study the E025 to slide to 4 and then do the exercises. Huh?
妈妈一路表演的，过去些的话产附近，那在被抓下来，不不的，他都是秒来的，也在用的，也在家中也在面的。
Now we're talking about the sinusoidal circuit.
And three topic is the analysis of the non-sinusoidal circuit. Non-sinusoidal circuit can be the square waveform or solid waveform. Those non-sinusoidal circuit, they are repeatedly coming from one path to another path. This we call it a Fourier series. So we can write down the mathematical equation for the all kind of the non-sinusoidal circuit. The circuit can be different from the square wave or solid wave. We can write down the composer formula. The formula is FT is equal to A0 plus A1 sine WT plus A2 sine WT plus A1 cos WT plus A2 cos 2 WT. This is the Fourier series. FT is equal to A0 plus A1 sine WT plus A2 sine 2 WT and plus A1 cos WT plus A2 cos 2 WT. So this is the composer equation for the non-sinusoidal circuit. So the A0 is a DC value, so DC current, DC voltage. That can be calculated by the equation 1 by T into integration 0 to T FT dt. So this is the T is a period, FT is a function. AN means that all the terms are representing the psi value. So this one we can calculate 2 by T integration 0 to T FT psi and WT dt. Similarly, Dn can also be calculated 2 by T integration 0 to T FT cos and WT dt. This is for the Fourier series. So we can calculate the A0, AM, Dn by the formula and we substitute here. And then for the A1 at the place of the n, you can substitute the 1. For the B1 at the place of the n, you can substitute the 1. By this way, you can calculate the series for the any kind of the waveform. So that all waveforms are connected to the supply, connected to the
And also the non-sinusoidal circuit set lesson 2.
So this is the circuit. So A0 is the DC source, A1 sine alpha, AN sine N alpha, D1 cos alpha, and DN sine N alpha. So those are the different frequency source. They are supplying to the linear network. So in this case, we can calculate the effective voltage. The formula is square root of V0 square plus VN1 square plus VN2 square divided by 2. VN1, VN2 are the maximum voltage of the source 1, source 2. So the VN1 square plus VN2 square by 2 can be written as a V1 effective square plus V2 effective square. So the V effective is square root of V0 square plus V1 effective square plus V2 effective square. Similar for the effective current. The total power can also be calculated. Power total is V0 I0 plus V1 I1 cos theta 1 plus Vn I cos theta n. Those are the non-sinusoidal current, the voltage, effective current, and the power calculation. Based on this principle, I will solve this problem. the voltage. So E, the resistor is a 3 ohm, capacitor is 1/8 farad. The input to the circuit is the E is equal to 12 plus 10 sine 2t. So when we find the current I and the voltage VR VC, effective value of the current VR and the VC, find the power delivered to the circuit. So this circuit is the two components. 12 plus 10 sine 2t. 12 is a DC source, 10 sine 2t is an AC source. So that firstly we consider only 12 volt is DC is supplied to the circuit. So when the 12 volt is supplied to the circuit, this is the for the DC supply. Only the resistor is a take by the circuit. If you supply the DC to capacitor, there will be a open circuit. Because the open circuits are there is a no voltage and a no current across the VR, so the VR is 0. Current is 0 and VC is similar to the supply voltage 12 volt. So this is the first condition. Only 12 volt supply, VR 0, I 0 and VC 12 volt. And we assume that there is supply by the 10 sine 2 is supply. So this is the AC. So sine 2D is a radian frequency. So the omega is 2. Capacity via the AC, 1/8 farad can be calculated, 1 omega C, so 1 omega is 2, C is 1/8, so that you got the 4 ohm. 4 is a J4, minus J4. So this is the source. In this case, our 10 sine 2 is supplying, so there will be the 3 ohm, and capacity is a minus J4 are connected in series. So that we can calculate to the impedance, there is going to square root of R squared plus AC squared. Minus 10 inverse AC by R. So that R is a 3 ohm, AC is a 4, minus 10 inverse, AC is a 4, R is a 3. By solving this one, so the impedance is a 5 angle, minus 53.2 ohm. Current can be calculated, voltage by impedance. Voltage is a 10 is a maximum voltage. So the effective value is divided by root 2 angle 0. And also the impedance is a 5 angle minus 53.2. So the 10 divided by root 2 angle 0 is divided by 5 angle minus 53.2. So by solving this one, what you got is a 1/4142 angle 53.2 ampere. This is the current. This current passing through the resistor 3 ohm, I multiply R. So the current is 1/4142 angle 53.2. This is the 3 angle 0. So the 4/24 angle 53.24. And effective value is VC. I multiply AC. I is a 1/4142 angle 53.2. AC is a 4. For there's only capacitor minus J4, so this is the polar force minus J90. So 1/4142 angle 53.2 multiply 4 angle minus 90. So the 1/4142 multiply 5/64, 53.2 minus 90 is a minus 36.8. So we can calculate this capacitor voltage effective value. So the current effective square is square root of DC current square plus AC current square. So DC current here is a 0, substitute 0. AC current here is a 1/414 square. So you got the 1/414 ampere. Power effective. Current effective square multiplied resistance. Current is a 1/414 square. This is side 3, so you got the 6 1. Capacitor voltage effective. Square root of, so DC voltage is a square, and AC voltage is a, across the capacitor is 5/64. Square root of square plus 5/6 square, so you got the 13.674. So this is for the non-sinusoidal current circuit. So we, based on the non-sinusoidal analysis, we can calculate the voltage current in the circuit.
Okay, so today's lesson we talking about the diploma. So advanced diploma electrical circuit. We use a lesson 1 resonate, lesson 2 are non-sinusoidal. So how to see this electrical? So firstly, I show you the which link you have to do. So you click that IUI College.com/electrical diploma 2022.htm. So this is the site. IUI College.com/electrical diploma 2022.htm. So this is the web page. This web page you got, and then this web page you can go down here and then up to this electrical YouTube video lesson for the electrical engineering lesson. So YouTube video for electrical engineering lesson, you click this link, and then you click the lesson. And then lessons you go down. So we printed the DC circuit, we printed the electrical assessment. Here you go the advanced electrical circuit. So lesson is a lesson 1 resonate, lesson 2 non-sinusoidal. That's 2 lessons. Regarding the written notes, you have to look at the page 14 to 25 or the following link. So that those are the video lessons. Those video lessons are notes you can get. You can get it. So the page 14 to 25. So you can download this link of there. So page 14 to 25. So this is you open page 14 to 25. You look at. So from the page 14 to 25, you can see the written lesson for the video that I explained for the advanced diploma electrical. Advanced diploma electrical, I explain you about the advanced electrical circuit, how to get those lessons and video. I show you on this internet website. And also those videos are based on a written lesson. So those written lessons are the page 14 to 25. Now we open in those written lessons. So those lessons that you can get at page 14 to 25, you can download and then you can print out and you can see the written information related to the video that I explain you. So now we are opening the video lesson. So find the download this we explain about our website. So if you log into college.com website, you go enter, and then you can see the weekly lesson. So weekly lesson link, we click the weekly lesson. Those weekly lesson for the electrical degree and diploma. So we have all these. This is the Bachelor Applied Engineering Electrical Electronic video. So we finished 3 sessions. 6 February, we explain about the overall program instruction. And 13 February, we explain about the electrical engineer practice, standard specification reassessment, electrical engineer workshop practice 1 for the trade 1. We explain about the occupational health safety workshop. Now electrical engineer trade practice 1 for electrical trade 2. So we explain about the lightning circuit. And also advanced diploma electrical electronic engineering, we explain about DC circuit. This is for the 13th February. 20th February, this is the video here. For the Bachelor Applied Engineering, we explain about the projections, configuration, maximum demand, calculation, AR3000 given. And also the electrical trade 2, environmental concern energy system, emergency system. For the trade 1, we explain about the workplace hazard, OHS school cutting, advanced diploma, we explain about the OHS and reassessment. Today is 27th of the February. Regarding the electrical engineers are trade practice. Bachelor of Applied Engineering, we explain about the specification development as well as the solution, configuration, production, configuration setting. And for the trade 2, we explain about the heater and also lighting. Also the trade 1, we explain about the working at the high use of the ladder. And also regarding the advanced diploma, we explain about the circuit, advanced electrical circuit and resonance. So this is for this is the video lesson here. This video lesson, you can see the page 25 to 14. So this is the sinusoidal and the resonance circuit. Sinusoidal resonance circuit, you can this is today's program. Today's program we explain about it quiz 25 to 40. No, this is for the lesson. Those lesson no, you can download from the internet website. Okay, so this is all for the today lesson. So I will post my lesson regularly to the website. The website you have to know that you go firstly you enter the www.iqitechnicalcollege.com and then the website iqitechnicalcollege.com. Then you can go down, you can see the weekly lesson. You click the weekly lesson. Every week, Bachelor of Applied Engineering Electrical Electronic video, we will be updating. So there are 3 videos has already been posted. 6 February, 13 February lesson 1, 20 February lesson 2. Today is 27 February lesson 3 I will post to website. And those lessons are include the Bachelor of Applied Engineering, Advanced Diploma, Electrical Trade, Level 1 and Level 2. So those things will be included and I will post it. So this is all for today.